page 264. I've opted against question 3. I won't do 3 and 4, I'll just do 4. I presume it's more challenging. But let's just go for 4 anyway. It says draw the graph of, let me just get this pen in order. Draw the graph of y equals x squared minus 5x plus 6. There you go, I've got to draw that. I've got to go from minus 1 to 4, usual thing, you know my style. Minus 1, 0, 1, 2, 3, 4. Not going up in halves this time, which is nice. Let's get this little table sorted. It's a bit fat, isn't it? Never mind. It'll work well. The last one across there, bring this down like that. Back to this. So I've got to work out y equals x squared. Take away 5 lots of x plus 6, get my answer. Whack it down here. And then get my coordinates on the right hand side. That's how I like to set up my table. Right then, so shove it in there. So I've got to go minus 1 squared, take away 5 lots of minus 1 plus 6, get my answer. Next one, very boring, 0 squared minus 5 lots of nothing plus 6, I'll get that answer straight away. That's going to be 6. 1 squared, take away 5 lots of 1 plus 6, that's going to give us 1, minus 5 is going to be minus 4, minus 4 plus 6 is going to be 2. What I'll do is pause the video, work it all out just to save time, and then I'll get back to you with a graph. Okay, welcome back everyone. What I've done is calculate all the coordinates using the x values from minus 1 to 4, going up in steps of 1 unit at a time. The corresponding y values are shown here on the right hand side, and the coordinates on the extreme right hand side of this table, so minus 1, 12, 0 to 6, etc, etc. The question says draw the graph. Well, I've been taking some liberties because on the other page, while you lot have been dozing, I've actually drawn the graph. So this is the graph of y equals, let's just state the equation carefully, x squared minus 5x plus 6. Is that alright? So I've just drawn it. It's a lovely, lovely graph. It's quite hard to draw on the screen actually using the graphics tablet. It's really beautiful. Now, just a point to notice, the points 2, 0 and 3, 0, when you completed the table, if you just go back here, you may think, wait a minute, how can we have two values of 0, one after the other? We changed the x value, okay, from 2 to 3, and in both cases you get an answer of 0. Well, it's completely correct. If you do the maths yourself, with or without, in fact I didn't use a calculator for this bit, you do get 0 and 0. So the point 20 is correct, and the point 30 is correct. Now, as you can see, if you see the coordinates in context, then it actually flows beautifully. As you can see, the minimum point there is somewhere around the x value of 2.5. So we've got an x value, minimum x value of 2.5, and sorry, the x value of the minimum point is 2.5. So it'd be 2.5 minus 0 point something or other. We're not asked for that, but I'm just saying, if you get 2 points that go, 2, 0, 3, 0, it looks like it's going to flatline. It doesn't. It carries on troughing below these 2 points to reach the minimum and then take off again back towards the point 42, which is the last point we calculated. So that is the graph, and so if that happens to you, 2, 0, 3, 0, don't be frightened by it. When you draw the graph, you'll see that it's correct. Right? Of course, if it doesn't look correct, you need to go back and self-correct as much as you can. Then it says, use your graph, there it is on the screen, use your graph to solve the following equations and give your answers correct to 2dp. Well, we'll try, but it's very hard to read 2dp off a standard piece of graph paper. So the first one I've got to solve is this. So I've got x squared minus 5x plus 6 equals 0. In other words, where does this y equal 0? Answer, along the line y equals 0, which is this one here. In other words, the x-axis, you know that. So we're looking at two solutions there and there. There they are. So the two solutions are x equals 2 and x equals 3. There's the two solutions. Oh, 3. That's that one done. Next one. I've got to now find the solution to this one. X squared minus 5x plus 5 equals 0. Right, okay, now remember the trick. We need to compare it with the original. X squared minus 5x plus 6 equals 0. What do? if you go from 5 to 6, we need to add 1 to each side, don't we? Alright, so if I was to add 1 to each side, this will become the original x squared minus 5x plus 6, because 5 plus 1 makes 6. Therefore, what have I got here? I must plot the graph of y equals 1, because x squared minus 5x plus 5 equals 1. Alright, so if y equals x squared minus 5x plus 6 and y equals 1, and these are equal, they're equal at the point of intersection with the line y equals 1. So I'm just going to draw in the line y equals 1. So from there to there, cut it straight across and try to read down here as carefully as possible. So that's one solution, and that's another solution. Again, let's just put a little arrowhead on it to show the examiner what we're doing. So I'm reading down that way, and this is the line y equals 1. So what have I got? I've got 1 point, it's 2 squares make 0.1, so that's going to be 1.3. I'll make that 1.4. There's no way we can get 2 decimal places out of this graph, and I've extended and expanded rather the scale to counting 0.5s. Look at it. So I'm going to go with 1.4 on that one. So x equals 1.4, and please note there are 2 positive solutions. This one looks like 3.5. It's not even 3.51. It's 3.505. So I would call that I would call it 3.51 to 2 dp. It's the best I can do. So 3.51 should be 05. There's only 1 square beyond the 3.5, but I'm sticking to the rules. It's 3.505. Then the 05 becomes 0.01. So there's my 2 solutions for that one. Let's get rid of that now. And finally, I've got to solve this equation. Go back to blue. I've got x squared minus 5x plus 2 equals 0. So let's just write the original above it so you can compare. I've got x. Oh, it's gone glitchy. Please don't do this. Minus 5x plus 6. Now, from plus 2 to plus 6, I need to add 4 to each side, don't I, to make it work. Then this will turn into 6, in other words this original equation, and therefore I must use the line y equals 4. So here I go, y equals 4. Grabbing this line facility here, starting there, cut straight across. In fact, I will cut straight across quite deliberately. Look, there's no other solution on this side unless I extend the line. However, I don't know where the line's going to go, and I've only been told to plot up to values of x up to 4. And what I'm going to do is try and extend the line just to see if there are 2 solutions. It's not obvious, but I'm going to go for it anyway. So if I was to extend the line, like so, I'm guessing there'll be 2 solutions. Of course, I've now come off the scale. What I'm going to do is get the one solution that's definitely correct and get a mark for that one. So hold it right there. I'd say it's there. Put a little arrowhead, show the examiner what I'm doing, and I make that 0.4 exactly. It's 2 squares before the 0.5. So therefore I've got x equals 0.4, and I'll take a crude judgment on that one. Again, we could discard it if the answer book doesn't want it, because I've actually come off the scale, haven't I? But I'm just showing there are 2 solutions. The only reason there won't be 2 solutions is because I've gone beyond the x value of 4, and so therefore I wouldn't be expected to have an answer in that region. But let me have a look anyway. So if that's 4, that's going to be 4.5, and 2 squares beyond that is 4.6. So these are my 2 answers, 4.6 and 0.4. So I'm going to leave it like that and then pause and get back to you if I need to make any changes. But the only grade A bit we've done really is where we've had to manipulate the 2 equations to restore the equation we want to solve back to the original by either adding 1 or adding 4 in this case, and so that will mean we have to draw these 2 extra little lines to see where the points of intersection are. Again, remember the point of intersection with the x-axis is merely the line y equals 0, so there's the 2 solutions there. The next line we used the line y equals 1, so there it is, y equals 1, and the 2 solutions are there and there. And finally, the last solution was for the graph of 2x squared minus 5x plus 2. Therefore, we need to draw the line y equals 4, and there was just one solution on this graph. But really, in reality, by continuing the graph, there would have been a second solution in this place here. Okay, so I'll definitely stop that, end of video, and I'll plan ahead. If I need to correct anything, I'll do that.